Welcome to my class 12 Physics, first chapter, Electric Charges and Fields. And the main point of discussion today, that is Gauss law. What is the statement of Gauss law? And before that, you know Coulomb's law. You know the statement of Coulomb's law. And by using Coulomb's law, you also calculate the value of electric field due to a point charge, that is 1 divided by 1 by 4 pi epsilon 0 q divided by, we write that is r square, q divided by r square, and this is the value of electric field for free space and in SI unit. You know that expression. That means, suppose we take a point charge, and point charge, that is suppose q, and the observation point is that this one is the observation point. Suppose observation point we write p point, and this is the distance of the observation point from the point charge. Then at point p, the magnitude of electric field E is equal to this amount. You know that. But Gauss law and by using Gauss law, we also calculate the magnitude of electric field at any point due to a point charge and also due to a continuous charge distribution. But what is the difference? In case of Gauss law, we can easily calculate the magnitude of electric field, and generally in case of Gauss law, we can easily calculate electric field in case of complex configuration. That means in case of complex configuration, we use Gauss law to calculate electric field. In case of simple configuration or in simple case, we use Coulomb's law to calculate electric field at any point. Clear? Then what is the statement? Statement of Gauss law. We write heading, that is statement of Gauss law. What is that? Statement of Gauss law. Simply we write electric flux through a closed surface is 1 by epsilon 0 times of total charge enclosed by the closed surface. Clear? That means simply we write electric flux through a closed surface. For electric flux we write, suppose symbol is equal to phi, is 1 by epsilon 0 times. That means is equal to 1 by epsilon 0 times of total charge enclosed by the closed surface. Total charge suppose q. That implies we write phi is equal to q divided by epsilon 0. This is the expression of Gauss law. Clear? And suppose we take a spherical closed surface. This one is the spherical closed surface. Spherical closed surface means this is a three-dimensional case. This is a three-dimensional case. And this point is the center of the spherical surface. We write that is O. And this is the radius. This is the radius of the sphere. Suppose this point is A. For radius we write r. And here a point charge is there. A positive point charge, that is plus q, situated at the center. A point charge plus q is situated at the center of spherical surface. Clear? Then at point A, this is the direction. This is the direction of the electric field, because you know direction of electric field is always outward from the positive charge. So that this is the direction of electric field outward from the positive charge. And your spherical surface looks like a curved surface, so that we take a very small surface area element. This is a small surface area element, and this small surface area element we write, suppose that is del S. This is a small surface area element, and the total surface area we write S. Total surface area looks like a spherical, and that is a curved one, but small surface area looks like not curved, that is looks like plane surface. Clear? And we draw the perpendicular or normal to this surface area, and this is the normal. This is the normal to the surface area or small surface area element, and this normal we write n cap, or we also write that is surface area vector, or we write n cap. N cap is the unit vector or direction of the area vector, because del S vector, that is area vector, and this is the direction of the area vector. Del S means that is simply area, or we write small area element, we write that is area element. Clear? And in this case, direction of the area vector is outward, and the direction of the electric field is also outward. That means both electric field and area vector parallel to each other. Parallel to each other means angle between electric field and area vector is 0 degree. This is the angle between E vector and area vector. Clear? Then at point A, what is the magnitude? Magnitude of the electric field, because charge is at point O. This is a point charge, that is plus Q. Plus Q is situated at point O. Then at a distance R, means at point A, what is the magnitude of electric field? We write simply electric field at point A is, for electric field we write E is equal to 1 divided by 4 pi epsilon 0, magnitude of charge is Q, square of the distance, that is R square, and this is in the scalar form. And in vector form we write that is E vector multiplied by, here a direction is there, we write that is R cap. R cap is the direction of electric field. Clear? Then what is the electric flux for this small area element? Only for this small area element. For this small area element means for small area element del S, what is the electric flux? We write simply electric flux for small area element del S is, you know the symbol for electric flux, that is del phi, because area element is small, that is del S, so that flux is also small, that is del phi. And what is the meaning of electric flux? You also know that electric flux means, suppose we take a area just like this, suppose this is the area element, suppose this one is the area element, and these are the electric field lines. These are the electric field lines. That means suppose electric field lines are perpendicular to the area element, then total number of electric field lines crossing normally to this small area element is known as electric flux. Simply, number of electric field lines crossing normally is known as electric flux. We write electric flux del phi. You also know the mathematical expression, that is E vector dot del S vector. That implies del phi is equal to E del S, this is A dot B, vector A dot vector B, that is vector A dot B means dot product, and we write AB cos theta. Here we write E del S cos theta. And what is theta? Theta is the angle between E vector and del S vector. This is E vector and this is del S vector. Both are in the same direction. Angle is 0 degree. So that in place of theta, we put 0 degree. We write del phi is equal to E del S, because cos 0 is equal to 1. Simply we write E into del S. Clear? And you also know the magnitude of electric field. That implies we write del phi is equal to, what is E? This is the expression of electric field for magnitude. This is the electric field. 1 by 4 pi epsilon 0. In place of E, we write 1 divided by 4 pi epsilon 0 Q by R square multiplied by del S. This is the amount of electric flux for small area element and for the whole sphere. For the total spherical surface, for the total closed surface, and this one is the closed surface, and this closed surface, in this case, this closed surface, in this case is known as the Gaussian surface. That is known as the Gaussian surface. Gaussian surface means that is a closed surface, that may be a spherical, may be a cube, may be a cylindrical, but that is a closed surface. Clear? And for the total surface, what is the electric flux? We write electric flux for the total closed surface is, in place of del phi, we write suppose phi. Phi is equal to summation of all the small electric flux, that is del phi, and this is equal to, phi is equal to summation of, we write 1 divided by, this is the expression for del phi, 4 pi epsilon 0 Q divided by R square multiplied by del S, and 1 by 4 pi epsilon 0 Q by R square we take out of the summation. That implies phi is equal to 1 divided by 4 pi epsilon 0 Q by R square summation of all the small area element, all the small area element combinedly, that is the whole surface, that is the whole closed surface. Whole closed surface means that is the spherical surface. So that total surface area of the spherical surface, you know, that is S, and S is equal to 4 pi R square. You know this formula. S is equal to 4 pi R square. So that in place of summation of del S, we put 4 pi R square. That implies phi is equal to 1 divided by 4 pi epsilon 0 Q divided by R square multiplied by, in place of this, we write 4 pi R square. Clear? And here 4 pi cancel, R square cancel, remaining is equal to Q divided by epsilon 0. Finally, we write electric flux is equal to phi is equal to Q divided by epsilon 0. This is the Gauss law. And we also write same thing. phi is equal to electric flux. This is a mathematical expression of electric flux. That is the symbol for closed surface. This circle for the closed surface. That means integration over a closed surface of E dot ds vector. This is the expression of electric flux, and this is equal to Q divided by epsilon 0. This is the statement or mathematical expression. We write that is mathematical expression of Gauss law. Clear? And here mathematical expression, you know, that is phi is equal to Q divided by epsilon 0. And in case of Gauss law, Q is the total charge inside the closed surface, not outside. Look at the figure. Here Q plus Q, here a point charge is there, single a point charge is there, that is situated at the center. But Q means total charge inside the closed surface, may be placed at this point, may be placed anywhere, but inside the surface. That means we write in this equation, Q is the total charge, that is the net charge inside the surface, inside the closed surface, not outside, inside the closed surface. And this is equal to, you know, integration over a closed surface, vector E dot ds vector, and your electric field. This electric field in this expression is due to the charge may be inside and may be outside. Clear? That means we write here electric field in this equation is due to the all the charges inside and outside. Clear? Electric field means that is the electric field due to the charges which are inside the closed surface and also outside. But Q means net charge or total charge inside the surface, not outside the surface. Clear? Then some special case is there. Suppose first one, we write case 1. Suppose no charge is there, or a net charge is equal to 0. Suppose in the absence of charge, a closed surface is there, and inside the closed surface charge is 0, no charge. Then in this case, what is the flux? Phi. You know the Gauss law, phi is equal to Q divided by epsilon 0. That implies phi is equal to, in place of Q we put 0, 0 by epsilon 0 means 0. That means finally we get flux is 0. That means if the closed surface enclosed, no charge, that means in the absence of charge, electric flux is 0. And another case, second case. Suppose a dipole is there. Inside the closed surface. Dipole means one is plus Q and another is minus Q. Then what is the total charge? We write total charge inside the closed surface is equal to plus Q plus minus Q, that is 0. That means if a dipole is situated inside the closed surface, just like this. Suppose this one is the closed surface. This one is a closed spherical surface. And inside in this closed surface, suppose two charge particles are there. One is plus q and another is minus q. And this is known as the dipole because magnitudes are same, nature is opposite, separated by distance. This is known as electric dipole. If electric dipole is there inside the closed surface, net charge is 0. So then what is the flux? In this case, flux is same thing. Q means total charge inside the closed surface, not outside, divided by epsilon 0, and in place of q we put 0. That means finally we get phi is equal to 0. Electric flux is 0. That means if no charge is there, flux is 0. If a dipole is there inside the closed surface, then also flux is there, 0. Clear? Suppose another case, another example, small example. Suppose you take a closed spherical surface. This one is a closed spherical surface. This one is a closed spherical surface. And this is the Gaussian surface. This is the Gaussian surface. And inside this surface, this is the first charge, we write plus q1. Another charge is there, we write minus q2. Third charge is there, we write suppose plus q3. Three charges are there. Then what is the flux? What is the net flux? We write in this case flux phi is equal to q divided by epsilon 0. That implies flux phi is equal to q is the total charge, and total charge is equal to, we write plus q1 plus minus of q2 plus third charge, that is q3, divided by epsilon 0. This is the total flux in this case. This is the total electric flux. Clear? And this is all about your Gauss law. And in the next class, we will discuss about derivation of Coulomb's law from Gauss law. Clear? And thank you.